good afternoon, everyone. Thanks for obviously joining. As sort of I've briefly sort of been mentioning there, this is obviously event number 2 of Python Live this year, obviously at Amicus. I'm sure you've all heard of us before, but obviously I'm Sam Smith. I'm one of the Python consultants here at Amicus. Obviously, we specialize in recruitment across 3 areas: so Python, machine learning, JavaScript, and Golang. So that's the sort of areas that we specialize in. Obviously, today I'm joined by Hayden. Obviously, Hayden is a Pythonista, sort of great Python engineer, sort of doing a talk on one of his sort of key interests, obviously, and key sort of parts that he works in, which obviously, as you've seen the title, which is industrial automation with Raspberry Pis. So yeah, really excited for this talk. Sort of can't wait to get it started. Obviously, the talk will last around about half an hour to 45 minutes. Throughout throughout the event, we'll sort of have opportunities to ask questions. Hayden's told me to sort of fire away any questions as we go on. So if you've got anything, please just put it in the chat. It'll reach one or two of us, and when we have a sort of moment, I'll ask the question. So we'll get some things sort of answered. So yeah, and obviously at the end we'll have a question answer sort of at the end. So do obviously fire anything away. So obviously that's probably enough from me. I'll pass over to Hayden to give himself a bit of an introduction and to go on with the event. So over to you, Hayden.
Great, thank you, Sam. I'm just going to start the slideshow. Right, so I'm going to just give you a bit of a background as to what I've been doing in this last sort of 2.5, 3 years through this slow process of mine. And I suppose it's going to be more of a story than anything, with a bit of tech injected here and there. So please feel free to stop me. I'm going to try to pack quite a lot of different things into this. So yeah, please do stop me and ask questions along the way if nothing makes sense, and I will do my best to help you. So just a bit about myself. Well, the contents, shall I say, of this talk. I'm going to talk a bit about my background very briefly, and then jump straight into the story of woe that led me down this path, and how I've made some partial victories along the way. And I'm specifically going to talk about Modbus, because this is a very useful thing that I've discovered, and it's a machine-to-machine protocol which any aspiring IoT guy should know. So I'm also going to talk about the pitfalls that I encountered with Raspberry Pis and how to get around them, and a bit more about, where I've come to now and where I see myself and the company that I've started going forward in the future. So a bit about my background. I spend half my time in Zimbabwe and half my time in the UK. I used to be, a long time ago, a research physicist. So in the bottom left there, I've got the molecule I used to work on. I used to do molecular simulations with that. Taught me a bit about programming and a bit about data science, which I now use in other fields. And I suppose I decided that academia wasn't really for me, so I decided to move into entrepreneurial stuff, really. And I've had quite a long history of being involved with different kinds of startups. The most recent one before my IoT thing was Pay, which is a company in Nigeria and Kenya, which does gig platform loans for people to fix their bikes and cars and get them back on the road. That taught me quite a lot about how to not approach business and how to deal with some of scaling issues, we could say. And in the UK, when I'm there, I build software for a fintech called Hugo. And I work as a senior engineer there and build sort of credit card transaction systems and integrations with crypto and gold. So I'm not going to talk about that today. I am going to talk about my IoT project. So let's get to the story. I've got a map of Zimbabwe on the screen, and you can see there's it's actually not on the map, but about 100 kilometers south of Harare, there's a little region called Beatrice, which is where quite a lot of farming happens. And one afternoon, I was having coffee in a cafe, and I was introduced to a fellow called Stuart. He was basically farming tobacco in this place called Beatrice, and was having some issues with his curing tunnel. So let me stop there now and just give some backstory on tobacco. So Stuart came to me with this problem, and I, at the time, didn't know anything about tobacco and anything about how it's grown, how it's cured, why it's cured. It was all news to me. So I did a bit of research. And what I found was that tobacco is one of our biggest export earners. It brings in about 600 million annually, which is, considering the economy is only about 15 to 17 billion large, it's a pretty sizable chunk of our GDP. It's also equivalent to the value of maize imports we require to feed the nation. So yeah, it's actually a healthy forex earner for actually importing the maize deficit that we have, or attending to the maize deficit that we have. So I got kind of more and more intrigued by tobacco and what people were doing with it, and I hadn't realized it was still going strong. I mean, 10 years ago, I'd heard that there would be no tobacco industry to speak of because, most Western and European nations have essentially, eradicated smoking from their societies. But little did I know that China, essentially, just as Europe was stopping smoking, just as North America was stopping smoking, China's just been ramping up their smoking habit. So yeah, it's not great for their health, I'm sure, but it's great for our economy. So yeah, I got intrigued in sort of seeing if I could solve this problem for Stuart and solve other problems, I suppose, in industry and agriculture as a result. So here's a picture of a curing barn on Stuart's farm. It's basically about a 60-meter long tunnel, about 2 stories wide. And there's a chap there just cleaning up the coal. So they use quite a lot of coal for the furnaces in these tobacco barns. And the question Stuart had for me was, is there anything you can do to help me measure my barn temperatures remotely? So at the time that we had this coffee chat, essentially he would have to get up in the middle of the night, get on his motorbike, drive to this curing barn, and go into a tunnel which is approximately 50 degrees inside at 100% humidity, and walk around through the 60 meters under supervision, because you can faint in there quite easily if you're not careful, and go through and check the temperatures at various sampling points within the barn. So the question he had was, well, is there something that would allow me to not have to get up at every 2-hour intervals in the night? So just a little bit more about the curing process. Essentially what happens is you have these giant turbines which drive air through the barns and pick up heat at a heat source, which I just illustrated here. And what happens is the tobacco comes off the field very green like that, about knee height, goes into the barn, and then is cured and comes out to sort of brown color. As you can see here, it's been loaded onto trolleys, and those trolleys kind of move through the barn slowly, and over the course of a week, this drying out process happens. So in that drying out process, what essentially happens is that the leaf moves through the barn, and the leaf moisture just starts coming down. And that's just because the heat, causes evaporation from the leaves, and tons and tons of water come off. At the same time, the temperature of the leaves slowly starts going up. And that is because as the water evaporates, it has less of a cooling effect. And so the temperature of the leaf at the very end starts going up exponentially. So herein lies the problem. It's a very thinly or finely calibrated thermodynamic process where you never want the temperature of the leaf to start falling. If it does fall, what happens is it reabsorbs water, and because the cells are brittle during the drying process, they then burst, and that reduces the value of the leaf. So you really just want a very fine gradient of temperature going up and never coming down. And achieving that is easier said than done. If you get it right, you'll make about $7 a kg. And if you get it wrong, you'll make about 50 cents a kg, which means you'll basically probably have borrowed $2 million and been unable to repay it. So that's essentially the problem that I was hoping to solve. Like, how can we get that temperature measurement system going really, really well and minimize the risk of losses? So here's a picture of a tractor just loading the tobacco barn with some tobacco. And here's the picture of what it looks like after it's been loaded onto the various trolleys and where it's about to be. Well, actually, that looks like it's partially through the curing process. It's brown enough to already be. So that looks like it's almost done, actually. So that will have been just passed through over the course of a few days on the trolley and been coming out the other side. So how to solve this problem? I didn't really have a clue, having never worked with any kind of hardware contraptions before. And I got talking to a chap who does crocodile farms, and he told me that he measured the temperature on these with a thing called a GSM commander, which is essentially a third-party device which allows you to pull out temperatures and transmit them via SMS from this little box, essentially. So you just put a SIM card in there, it absorbs the temperature data and then transmits it by SMS. So that for me was half the way there, because I definitely wanted the temperature data, but I wanted something more extensive than that. I wanted to be able to take temperature, as data points and have a whole history of it by time. So my plan was to build some kind of SMS to HTTP converter, which would allow maybe a mobile phone or something to just take this SMS and push it into an HTTP message that I could then unpack with my server and use it to capture data over time. I also realized I needed about 200 meters of cable to fit sensors in these barns, and I found that this particular GSM commander type device comes in a rather clunky box. So I ended up going down to South Africa and buying one of these boxes, and it was it was pretty hefty thing, like really to sit on my lap. It was just big, and I had no idea why it needed to be so big. But there you go. It was a bulky thing to get, which was definitely a downside when you're trying to import it from another country. So with that in mind, I got together all of the components and started building this thing. And the final sort of model of it looked like this. I would have my temperature, as you can see on the left there, feeding with wires to the GSM commander. The GSM commander would then send SMSs containing the embedded sensor information. A phone that I had just sitting on my desk would then receive that SMS and with a simple app convert it into an HTTP request, which would then go to my server, and the server would unpack that data and put it into my database so that everyone could have a look at it online. So in theory, that was an amazing solution. We put this thing in place, and lo and behold, the woe began. I had not anticipated many of the problems that we saw, but we found a lot of problems. The first of all was laying the 200 meters of cable. The barns, as I mentioned, are about 50 degrees and more if you're actually trying to lay sensors in the ceiling, and the humidity is close to 100%. So in about 20 minutes, you're close to fainting, and you start feeling very, very nauseous from the sheer quantity of nicotine your body is absorbing, and your heart rate goes out of control, and you just can't stay in there for long. So it took us quite a few days to actually lay the cables and set the sensors in the right place. So it really made me wonder whether it was going to be a scalable solution given that problem. But the most important problem we faced, or the one that was simply insurmountable, was that signal was very low in these remote areas, so you have to have this sort of high antenna to pick it up. But worse than that, there were just constant power cuts. So what would happen is the mains power supply would go off, the tower would switch over to diesel, and the diesel would run out, and then your cell phone tower would be dead for several weeks at a time. And no cell phone tower, no SMS, no data. So we tried this for a good 3-4 weeks trial, and maybe worked a week of that. So farmer really wasn't very happy, and yeah, it was a huge fail, and got me having to rethink the whole problem. So it was at that stage that I wondered, well, maybe, just maybe, we can just stop trying to use third-party stuff, which is pretty expensive and doesn't do what we want, and just build the whole thing from the ground up. So that's what we did. I thought about, maybe catering to new needs, pulling data and pushing it so that we could try to actuate some things at the farm. And on top of that, I noticed that there were, a lot of the feedback systems in the farm already worked with sensors. So the question was, could we use these sensors that were already there rather than laying 200 meters of cable with new ones? I also noticed that the kit, the electronic equipment inside the barns had what was called Modbus ports on these things called PID controllers, both of which were kind of new to me. I hadn't really heard of PID controllers, and I was vaguely familiar with the notion of Modbus, but had never used it before. So the question was, how could we use Modbus to interface with these PIDs and get something useful out of them? So here's the curing dashboard that you see inside the curing tunnel. Basically, it consists of a bunch of knobs and dashboard data. Those sort of the square things with red and green writing on them are what are called the PIDs. And the slightly sort of big, more rectangular ones in the center that you can see on the screen there are fans. So basically what happens is that they change the values on these PIDs, and the PIDs attempt to adjust the conditions inside the barn to what the farmer wants. And it's these PIDs and the bits and pieces that have the Modbus connections in them. So I was keen to see, like, well, how do we actually just plug into there? How do we read that data out of it? How do we push data to there if the farmer wants to change a setting? So basically, PIDs are what are called proportional integral derivative controllers. That's just a fancy way of saying that they will try to adjust something to reach a target, and if they overshoot that, will try to adjust either down or up to keep it at a specific rate or a specific value. In this case, with the curing barns, what we've got is PIDs are connected to a fan and a heat source, and they try to adjust both of those things in order to get the temperature to stick to some kind of target value. So that red value you can see on the screen is the actual temperature measured in the barn, and so it tells you basically what reality is. And the green value is the set value, which is the value that the farmer is trying to achieve, or trying to get the PID to achieve by adjusting through its own whims the heat and the air through rate. So a bit about Modbus. I didn't know anything about it really. I just seen it on the back of various packets. And to my surprise, it's something that's been around for a very long time. It was a protocol developed in 1979 for use with programmable logic controllers, but it seems to me that since that time, it's become a much broader communication protocol for machine-to-machine devices. So not just programmable logic controllers, but all kinds of different kinds of communications between computers and devices, and between devices themselves. So the way Modbus works is quite interesting. Essentially, it's a very simple protocol. It consists of a bunch of data packets which are sent from a master and received by a slave. And each of those packets contains a device address, a function code, a register number, a register count, some data. In our case, this would be temperature, and a checksum, which tells you, if there's been any errors in the communication process. So if we look at the setup that I tried to make with this, essentially my plan was just to take those PIDs, set each of them to a different device number. I've got 3 here as an example. Each of those would have a different address, which I would set. And then I would use a Modbus converter, which would allow my USB port on my Raspberry Pi to essentially send and receive messages with the Pi as the master. So as an example of something which would be sent here, I've got a packet of data here in the table. So in this case, we would send a message to device with address 3 from the Raspberry Pi. And so a message would be sent through the converter, would arrive at device 3, and the function code would say, okay, this is a read request, and it would ask for register number 138 and count just one address from 138. So basically just everything that's in address 138, and get the data, which would be 59.6 degrees, and to send that back to the Raspberry Pi. So in this particular case, with that packet of data, device number 3 would yield its temperature for the PV value and send it back to the Pi, which I could then do what I wanted with. So I set this thing up. I've actually got a PID over here with me. As you can see, it's just like that thing on the device dashboard. It has a PV and an SV, and it will plug one side into the mains, and the other side, those two things essentially plug into my Raspberry Pi device. So the next problem we had, okay, assuming that we could use Modbus with this Raspberry Pi to read data off these barn instruments, the next problem was, well, how do we get this stuff now online, considering that the towers are all down? And at this stage, what became apparent is that all the farms have internet, usually at their main office, so they can conduct business, and this is almost exclusively on satellite. So rather than actually try to reinvent the wheel, we decided to just piggyback on the satellite. So that's what we did. We got these long distance devices like this, which are essentially long distance Wi-Fi, which can send data up to 3 kilometers, and we would put one on one side in the barn and another one on the other side to receive data inside the main house or in the office. And we would just transmit the data straight from the Raspberry Pi, which would just be basically have a Wi-Fi connection to the long distance box. And that would then arrive at the office and get relayed straight to the internet. So that kind of took all of the reliance of cell phone towers out of the equation, which was made us very happy. And interestingly, the cost of production was like orders of magnitude lower. The GSM commander and all of the 200 meters of cable and everything cost me about $2,700. And the Raspberry Pi thing with my little $8 Modbus converter from China, which I believe is here, this thing I found was the best one of all. It's cheapest and most stable, costs about $7 a piece. That has worked wonderfully to just do the Modbus conversion for me. So all in all, that all just came to about $140, including a case. So I was staggered when I saw this, because we had full control of the system. We could push as well as pull data. We could get it piggybacking on the internet that was already there, so there was no extra satellite cost. It was just really powerful, and it came in at $140 versus $2,500. Also very, very small. I mean, I'm holding up my whole box here. As you can see it, it's basically, I put a lid on this, and it's very, very simple to ship around and assemble. It's nothing like that big bulky box that we bought the first time. So yeah, it was an unbelievable win-win situation. The next thing I'm going to talk about is a little bit about our system setup and the software, because, you know, it's very well to have a Raspberry Pi, but how do you actually get it to do the job it's supposed to, really? So I used Python to do all of the communications, that is to like scrape data from the device, push data to the devices, and then also make, you know, a request to my server to deposit the data. I started off using AWS. Essentially, I was using their serverless API, Aurora serverless. And, you know, in theory, it was great because it would scale well, and everyone likes to talk about scaling. But I quickly realized with my calculations that it would be very predictable kind of scaling. And since the packets of data are so small that using anything on Amazon just seemed like an expensive waste of time. And so it turned out to be. My Amazon Aurora serverless bill was about $150 a month. And right now, after changing to Linode and just using a bog standard VPS, I've got that right down to $8 a month. So almost negligible for all of the clients that I've got. So the library I depended on for doing my Modbus is something called Pi Modbus, which I encourage everyone to have a look at. It's yeah, it's a very good little library, very easy to use. One other thing before I actually show you some software is remotely managing the Raspberry Pis. For anyone who has got IoT things running on Linux, I thoroughly recommend a company called Tailscale. Basically, with them, you can just download a very, very simple script and install that on your devices, and that gives you pretty secure SSH access to all of your boxes without having to worry about, you know, your tunnels and all kinds of, you know, things which I don't like having to worry about. And I think I can get 100 up to 100 Linux devices with them for almost I think it's like, it works out to like $12 a month or something. It's very cheap, less than 30 cents a device. So for me, that's yeah, so it's a very useful way of just being able to log into these things. If anything goes wrong, sniff around, see what's happening, and be able to do upgrades and all sorts of things without having to actually go to the farm. So I'm actually going to just stop here and just bring out my actual code. So basically, can you see that okay, Sam?
Yeah, I can view that well. Can everyone else in the chat? Can everyone else see Hayden's code? Excellent. Yeah, looks. I think everyone else. Well, Tom's replied saying he can see that. So yeah, I think everyone else can see it.
Okay, great. So it's very, very simple. This is the main script that reads. Should I say reads temperature information from those PID controllers and sends it to the web server. This obviously runs on the Raspberry Pi. Basically, yeah, I import a library that I've built. I basically read the configuration, which tells me what the device ID is that I've set. So for which Raspberry Pi is on which farm, and that config file is unique to each Raspberry Pi. I then do what's called build the PIDs, which is the PIDs are what I call the PID addresses. So essentially, every time the Pi does a scrape, it first checks the server to see what PIDs it should be checking. So I can actually configure that straight from the server and tell it, okay, read this one now, don't read this one. Okay, upgrade this PID to a different address. I can customize it straight from the sort of admin panel on my side. Then I run a script just to read the addresses. For some of them, when I'm testing, I do a simulation. So if there's a simulation variable set inside the config, I just I run a simulation rather than actually trying to connect to the devices. And then I just connect to Modbus. I'll wake up the PIDs. Some of them need to be woken up. Won't go too much into that. Then just read the slave registers, close the Modbus, and then write everything to the server. And that just runs on a cron job every minute. Very, very simple. So just looking at the classes that I built themselves, it's very, very simple. Here's just like where I write the slave registers. I basically get a slave address from the server, read the value from the PID, and then write it. So actually, this is the that's writing this registers. Let's look at the read. Yeah. So the read is very easy. I essentially just go and look at all the addresses that were specified from the web or from the web call it made to the server, and loop through each of them, and then attempt to make a call and read each of those registers in turn. If it can't read it, which never happens really, I just give it a slave value of -999 so that I can do some troubleshooting and see how often it happens. I also send a log when that happens, really, and put in a small delay between each one that it reads, just a few milliseconds, just so it gives the device enough time to recover. And that's it. Just takes that information that it's got, and using this script here, writes it to my servers, and it's that easy. So now I'm just going to show you what it looks like when it comes out. Here's a live reading of a farm, actually not Stuart one, and another client of mine. I've tried to build a GUI which kind of mimics the board, so that the layout on the screen is exactly like how they have on their curing barn tunnel, dashboard. And so you can see the PV and the SV there. And if I want to, I can click on that SV and actually just change the value, hit set, and it will push that straight to the barn right as we speak. And get all of the fans and the whatever else is connected to start adjusting itself just in response to my sending a new value to one of these things. I've also connected up the fan. So here we've got fan readings. We can't unfortunately yet push settings to them, but it tells us what speed the fans are running at. And here is just a plot of the data coming through. This guy has actually got quite dodgy internet connection, even with a satellite. And so you can see it's a little bit sketchy in places. But I mean, basically, every minute on the minute, or he will get all of the data that he needs for each of the sampling points in his tunnel. And that allows him to just know in the middle of the night, without having to get on his motorbike, exactly what's happening in that barn. And the good thing about this is that usually, I mean, if the conditions go out more than 40 minutes, so if the temperature goes out for 40 minutes, you already start losing value. So if you're checking your tobacco in the night every 2 hours, you can already have lost sometimes up to $100,000 in a night if you've left something go drastically wrong. And that does happen. You can have like problems with the coal boiler. You can have people falling asleep who are supposed to be putting coal into the stokers. All kinds of things can go wrong. So having this kind of, the at your eyeball 24/7 really helps. You can do a kind of time scale here also if you want to see what's been happening over a longer time period. And I've also got a graph here for the fans, and it's that simple. There's nothing really more to it. They can also set up alerts if they want. So over here, they've got a parameter that if it goes out of this particular range, it will send an email to someone. And that's it. It's that simple, really. So I'm just going to skip those coding bits and pieces that I saw. showed. So just to come back to the stack briefly, the stack is basically just Python and Django. So I'm using the Django REST API to collect data and inject it into a database. And it's just being stored in MySQL. And for the graphs, I'm using Chart.js. Yeah, that's it. It's been very, very, very simple to put together. And I don't know if anyone out there uses Pandas much. I love Pandas, and I found that there's a Django Pandas plugin, which really makes extracting data and reordering it for the purposes of graphs very, very, very easy. You've already seen the GUI. I've shown you live. So last but not least, I just want to go through some of the pitfalls that we had with the Pis. I've made it sound like this was all just plain sailing, but for the first trial that I did last season, it was a total disaster for another reason. What I discovered very late in the day is that Pis are very, very sensitive to power. And the remote areas not only have unstable power from the point of view of having a lot of power cuts, but they also have wildly fluctuating voltage. So I've measured voltage on some of these places at 150 volts to 300 volts, anything in between that. And what I discovered very, very late in the day and after much pain was that when Pis are underpowered, they preserve their CPU integrity by killing tasks. They do this without telling you that they've done so. So what I suggest to anyone who uses Pis in the field is, number one, make sure you do not use the official Raspberry Pi power supply, because it's really bad. And most of them that I measured are delivering about 4.9 volts, so much beneath the 5.3 that they are touted as. And secondly, put in an uninterrupted power supply, which is, forces the voltage in to be roughly 220 volts. If you don't have that, you are going to run into big power issues. The one that I use is something I get off Amazon. It's a little silver box. I really like it because it's a very stable power supply and you can tune it. So I usually get them and ramp up the voltage to be about 5.3 to 5.4 volts, because at that level, even if you get a bit of a dip, so long as the Pi doesn't drop beneath about 4.8 volts, you'll be fine. If you're wondering whether you've had a throttling event, i.e. the CPU trying to recover itself from low voltage, you can run this command over here. And if you do run it, and it has had a throttling event, you'll get this code out at the bottom. And you'll know then that something's been throttled in order to preserve the CPU. And as I discovered the hard way, since you don't get any messages, all that happens is that things run without failing at all. I would get the call going through to the server just fine, but I would look at the server and find nothing has arrived. I'll go back and I'll be like, what is going on here? This thing has started this job, it's executed, it sent something to the log file saying that the request was successful. And then I would go to the server, just see no data. So essentially what happens is these throttling events happen on the sly when you don't know about them, and they essentially don't break enough of your system to send warning messages or errors a lot of the time. So yeah, it was very, very odd. And as soon as I corrected that power issue, the Raspberry Pis worked 100%. I have never had any downtime issues with them at all. They just work like clockwork. Every minute on the minute, they fire up. And the few times that I have had downtime, phoned the farmer up and I find that he's having a storm. His internet connection is just not working properly. So with all of the whole tobacco season, I haven't had a single farmer come to me with any problems with the system so far. So the current situation, I've got 15 clients in the field, a fish farm in Mozambique. that's the subject of another story, but essentially, now that this thing works on Modbus, I can basically plug it into almost any industrial system. So the fish farm measures entirely different things. It's got measuring dissolved oxygen, pH, phosphates, all sorts of things, nothing to do with temperature and humidity, but very, very similar principle. I just plug in, I scrape the data, send it to the thing, draw a slightly different graph because it's slightly different parameters, and there we have it. I'm hoping for 25 to 30 tobacco clients next season. We're just actually closing up the season now. So, end of March, they'll stop curing. So next season will start in October, so I'm gearing up for that. And hopefully there'll be 25 to 30 clients for that. And I retail them at about $2,500 to $3,500 to install, and then they pay an $800 recurring fee annually. So I really like it as a business model, because before I've been working with these things which you're trying to squeeze a cent out of every user, and you need vast volumes of users in the millions to begin making profits. And I find a lot of the time with those things, your costs are scaling faster than your revenue, and it's a real nightmare. With this, it's been super easy. Very small number of clients, very high value. I'm still only using an $8 a month server. I don't anticipate that changing until I've maybe got 200 farms on the cards. So very, very low overheads to run. Here's a picture of the fish farm in Mozambique I'm working with. They're called Jacoa. I'm hoping to use the pilot that I'm running there now as a basis for expanding into fish farms in the area. All kinds of other frontiers are wide open for exploration. On this front, there's crocodile farms, grain storage, warehouse storage. I think just in and around Southern Africa, there's about 1,000 farms and industries that I've identified as potential targets. And all of them can basically be run off Raspberry Pis. It doesn't matter what you connect to them. I've connected cameras to them. Here's the water monitoring device. This is an RFID monitor here. All of them basically just, they connect in very much the same way. So it's a very, very easy and extensible system.
We've just to interrupt. Sorry, just to interrupt. Hey, we've had a question from so one of the participants here, and they've asked what's the name of the special power to supply the stabilized voltage of the Pis. What's that sort of product you've got?
I actually don't know what it's called. I can provide the link. I actually just get them on Amazon. They're about $12 or just under 12 quid, I think. And they kind of brandless, but I've tested them and tested them and tested them, and they are bulletproof. Their marketing could probably do with some improvement, but the quality is great, and you wouldn't think it. I mean, it doesn't really look the part. It's just kind of grated silver thingy with some screws in it. So it's really not attractive, but it really does the job much, much better than any of the official Raspberry Pi chargers.
Excellent. And you're happy to provide the link for that sort of after
I'll actually, as soon as the talk's over, I'll just
we can jump on that. Excellent. And I believe someone else had raised a hand in the sort of chat box, but I didn't see anything come in. Have we? If you've got any sort of questions, do sort of leave them. As sort of said, just leave them in the chat, and we can I can just interrupt Hayden quickly and sort of ask him. But here we go then. So can Pis work on batteries powered, or sort of how sort of? That's a question from Faris.
Yes, they can very easily. So for the fish farm, I've also got a thing sitting out in the middle of the lake, actually about 1 kilometer into the lake, and that runs just off solar. So for those of you who know Raspberry Pis, you'll know they only consume about 12 watts. So my setup is to have just a 100-watt solar panel connected to a 12-volt motorbike battery. And that motorbike battery is 12 volts, but I then step it down to 5 volts for the Pi. and that works very well. I haven't had any issues there. That's also pretty stable. In fact, actually, I would say it's better to use a battery in some ways, because you don't have, at least in this side of the world, you don't have to deal with the prospect of huge power surges and things like that. So you know, the sun's pretty standard, delivers you 400 watts per meter squared, and that's the end of it. Even on a cloudy day, you can anticipate it. And yeah, so I would say it works perfectly with the battery. I've only really tried it so far with you know, solar power or solar panel to 12 volts, 12 volts, step down to 5 volts, and I've had no problems with that at all.
Excellent. Yeah, I think that's answered the question. And Nathan sort of made a comment that sort of that device type thing we were on about was is most probably a UPS, an uninterruptible power supply. Is sort of I take it that's sort of what that device is called, is it?
This one.
Yeah, that device, yeah.
I mean, it's technically, I wouldn't say it's a UPS, because it doesn't. I mean, it's just I would say it's just a converter. I mean, it's step down 220 volts to 5 volts. That's it. I wouldn't say it's got any fancy UPS properties. I mean, I usually think of a UPS as having like a surge protection, and also sort of more intelligent voltage modulation, which this definitely doesn't have. It just allows you to twist a screw and fine tune the voltage to something, and I like it on a high side. So if you put it at like 5.4 volts, 5.3 volts, means that even if you do get a dip, you're not going to start getting throttling of the CPU.
Brilliant. And obviously, as we said, we'll get that sort of link to the exact device shared for you all. So we can, if anyone's sort of interested, they can obviously look at that after as well. But I'll uninterrupt you and let you carry on.
Okay, we're almost out of time, so I'm just going to go over what I'm going to be doing next season, which I'm excited about, and that's the leaf classification, because at the moment, a lot of the farmers pay quite a lot of money to an expert to come and look at the leaves and, you know, tell them, you know, what they should do to tweak it. And ideally, what I want is a system where we take photos of the leaves at sort of various sample points, and we specifically relate them, what those leaves look like, to the conditions that the leaves were exposed to. Then we get an expert to classify the leaves, and we train an AI model on the known leaves, so that we can classify unknown leaves and give them a quality score, and basically just have a nice way of marrying up what the quality of the leaf is to the conditions that they've been exposed to, hopefully without paying lots of money to an expert to drive 4 hours to your farm and walk around in the heat. So that's what I'm developing for next season, with some AI image recognition, and looking forward to trialing it. So I mean, the more I look into all of these industries, and the more I see the power of the Raspberry Pi and Modbus, the more enthused I am, and the more opportunities I see for huge improvements to processors. So just in conclusion, to summarize everything, the Raspberry Pi is a really low cost to build these solutions with. I mean, you saw $140 versus $2,700. As soon as you sort out the power issues, and sometimes that can add a bit of extra cost to it, they're very, very reliable. I literally, with those cron jobs, they run every minute on the minute. I've never had a downtime in all of the months that they've run. It's just clockwork. Modbus, I can't recommend highly enough. Most devices that you get these days will come with a Modbus portal of some sort. Even if you can't get them with Modbus, you can sometimes get analog to Modbus converters, so that even if you're having to connect to sensors which don't have Modbus, you can actually get a little device which the sensor will go into, and that device will then convert it to Modbus. And I find Pis are just very, very easy to use Modbus with. It's much, much easier than trying to like do what some of the hobbyists do, where they, you know, soldering in the back of the Pis and they're, you know, jamming wires in and out. You know, you just get one of these USB sticks, you plug your Modbus there, any number of cables in at the same time, and it just works like magic. So yeah, that's it really. I'm looking forward to making some more tailor-made solutions. I'm looking at an RFID system. The the cameras for backing up some of the monitoring that I'm doing, and further kind of improvements with monitoring using Tailscale and other things. So yeah, that's it really. For anyone who wants to contact me, just use my Gmail, hayden.eastwood@gmail.com, or check out my business page, risosense.com, or just ping me a WhatsApp. I'm on my Zimbabwean WhatsApp number all the time, even when I'm in the UK. And just get hold of me. I'd be happy to chat anything through at any time. And finally, thank you very much to Sam for organizing this opportunity for me. I usually actually, when I lectured back at university, I used to love doing it, and I never really get to do this, although this is the first on Zoom. So
no, it's been
difficult about the feedback, but yeah, thank you to all of you too for your time this evening, and I hope it gave you some interesting thoughts, and I'd love to hear any ideas that you may have for your own Raspberry Pi empires, and who knows, maybe we can even collaborate.
Yeah, obviously we've got a few sort of minutes for some questions, I think, haven't we, Hayden? So I think there's been a couple that's been fired in already. So obviously we'll run through a couple of these if you've if we've got time, which is initially sort of first question we've got is that do you have like a large data sort of set for healthy and unhealthy leave? Where have you sort of collected that from, I suppose? And then sort of how many image samples would you have for sort of each type to do that sort of next sort of step?
So it's very, very in its infancy at the moment. So I don't have enough pictures at all. So actually, I've got a couple of farmers working with me now who are helping to classify leaves. And it's quite interesting because they don't always agree on what a good leaf is, or they give it slightly different ratings. But yeah, it's going to be a big challenge because I've got to get that data set together. I'm hoping to classify, just say, 1,000 leaves into various bins. I don't know how yet to do it, whether it'll be good, medium, bad, or whether it'll just have a score from 0 to 1. With gradations. I'm not sure yet. I'm still thinking that through. I actually don't have a huge amount of experience with AI, with image AI, should I say, and image classification. So if anybody out there has some great ideas, I'd love to speak to you.
Brilliant. And then another question come in is, do you need to update any of the operating systems or like security updates or anything like that?
Yeah, this is something I'm still working on. So basically, with that Tailscale connection, you can log in and run your usual updates and things, no problem. So you can do that remotely. It's good. The next stage will be to sort of basically have an automated script which will log into them, run the updates, do some housekeeping, and then log out again. So that's on the cards for next year too, but it shouldn't be too difficult because that Tailscale allows you to do some quite powerful things.
Brilliant. And then another question from Tom was, how does the Raspberry Pis authenticate themselves to the line node VPS?
So at the moment, they've got a device ID, and they just have like a password that I set on the system. So that's basically specified in the config file. And so, yeah, they have a unique name and password. To be honest, I haven't spent a huge amount of time on security. I can't imagine, or maybe that's foolhardy of me, that something like this would be a target for hackers. And it's, it's also all backed up, and it's easy to start back up again. So my feeling is that I put in some security. I'm sure it could be better, and maybe someday it will be.
Brilliant. And then sort of, I think final question that we've got initially, unless anyone else sort of jumps in after that, is that sort of, would you use sort of drones on the farms? Could that be used in this sort of similar setting? Yes,
I mean, there's just so many things to optimize on these farms, because I'm just looking at one small thing, which is the curing. But of course, there's a vast unoptimized process of growing where I mean, I know some guys are using drones, and I've actually been experimenting with long range, what's called LoRa frequency, where we put probes in the ground in various sample points, and we get localized climatic readings. So you get your like soil moisture, soil temperature, all of the key irradiance from the sun, and you use that in conjunction with other data. So I mean, there's a big prize, I think, to be won for being able to marry together all of these data sources into a really wholesome picture for a farmer. The trouble at the moment is that, and I'm finding this as a real pain, is that everybody's got their own company for doing something, and nobody shares their data. So like, for example, the guys who are running drones don't have an API for me to be able to like drill in and get their drone data so that I can marry it together with other tobacco data. So, I mean, hopefully guys will come to the table a bit more, but it's really tricky with data because I suppose a lot of them regard their data as their core asset actually, and their service as their second asset. So getting them to part with it is difficult.
Excellent. And I think we've got one final question from Julian, was have you ever used, I believe it's pronounced Belenia, or BELENA, for managing Pis remotely? It's on the Q&A. I think there's a link there as well, Hayden. I'm not sure what the link is. But
let me look at the Q&A here. I haven't used Belena. I will certainly check it out. I haven't used it at all. Thank you for that. I will definitely check it out. I tried a few of them actually. Tailscale was the best solution so far that I found. I tried a couple of other ones which were just bad. They just, they would fall down and just not work as they said on the box. And it's a real pain when that happens because, a lot of these farms are 3 or 4 hours drive. So to like put some diesel in your truck and go out there is, it's, costs you $200 a shot sort of things. So you have to pay any amount of money to get your IoT infrastructure, working properly. I think it's worth it.
Excellent.
So thank you for that. Yeah, check it out.
Fantastic. Well, yeah, it looks like the questions have stopped coming in. So obviously, just wanted to take the time to obviously thank Hayden. Sort of really interesting sort of talk. I thoroughly enjoyed it and learned quite a bit myself. So I'm sure everyone else who's more technical than myself got a little bit more out of it. So yeah, obviously, if anyone's got any questions, Hayden said obviously as the sort of talk was sort of delivered, that more than happy to answer them, just to reach out and contact. Or if you struggle to get in touch, reach out to myself. I'm always sort of in touch with Hayden. Obviously, on another note, if you know anyone that would be interested in the talk, sort of this will be going live on our sort of social event, our social platforms, YouTube, etc. I'll be writing obviously my LinkedIn post about it in the morning. So yeah, do sort of comment, like, share, etc., or share around sort of the rest of your teams if you've got anything. And as always, obviously, always looking for new people as well. And sort of sure Hayden will be we'll do another one with me, I'm sure, in the future with other exciting topics. And yeah, please look out for the other events we've got going on the rest of the year. And yeah, thanks for your time, everyone. Thanks for joining on. And yeah, thank you, Hayden.
Thank you, everyone.
Excellent. Have a great evening, all. Speak soon.